This is the first in a multi-part series covering the custom stroker engine build performed by champion engine builder Bill Travato at BTR Performance for our turbocharged 1971 Olds project called the S71. Although this video series features an Olds engine, the valuable race-proven techniques shown by Travato apply to any performance engine build.
The Olds diesel block is a real good foundation for any sort of a performance application. We're doing this particular Olds build here with a diesel block. These Oldsmobile diesels were made in the 70s, and they weren't a very good diesel engine by any means, but they were a very good foundation for a race block. They have very thick main webs as compared to the gas blocks. The gas blocks have, it's very, very thin in this area, and what will happen is the block will tend to want to spread apart under power, and they'll crack in that area. But the diesel is a real good foundation. They have very thick cylinder walls, very thick main webs, basically very thick anything. Externally, they're the same as any gas motor, same deck height, same bore spacing. Everything will bolt right in, but they're just a beefy motor. The other advantage is it accepts a big block crankshaft, which allows more stroke, more cubic inch. It's all good. You can never put enough stroke in an engine. So, perfect candidate for this build. The only other thing that's a problem with these is the big lifter bores. The diesels came with 921 diameter hydraulic roller lifters, and no one makes them nowadays. So you typically have to either bush the lifter bores with bronze bushings to an 842 diameter lifter so that you can use conventional stuff, or we're going to try this build with the factory hydraulic lifters that came in that diesel engine. Very, very big lifters, but I think they'll work just fine. When choosing the machine shop or the facility or the engine shop that you want to work with, that you want them to help you achieve your goals, do your research. If you go into Google as an example and type my name in or my company's name in, you will find a whole array of things that I have physically done. Setting records, popular hot riding engine master challenge, all doing quite well in all of these things. But I'm easy to be found. I've done enough things where if you go search on the internet, whether it be go to my website at btrperformance.com, or you simply find that the phone number's on there, you give me a call and have a little conversation, you can physically see that I've accomplished some things. So hopefully that would be one of the reasons why you would come to me, is back to the achieving goals thing. I can help with that. I've been there. The way you identify Olds engines typically is the pad right in this area. When you see a big block, they usually have a large letter F. When you see a small block gas, they usually have a large number like a 7. When you see a diesel block, you'll see this D3 in this area here and this little raised hump. Also, they will all have this little 350 DX right there, and that's another way of identifying it. The machining of this block was done on our Cincinnati CNC. Basically what we do is we locate off the dowel pins that hold the cylinder head on. Those are your datum points, and at that point we know X and Y to the first bore is this dimension. We know what the bore spacing is, so we just tell the machine to put these bores wherever we want them. So we basically blueprinted the block. Cut the deck perpendicular to the bore. It's exactly 45 to crankshaft center line. I mean, it's a fully blueprinted block. The other area that is different from the gas blocks and the diesel blocks is they have big block Olds main sizes. So physically, a big block Oldsmobile crank will fit inside, and typically what guys will do is they'll use a 425 crank out of the old 65 to 67 425 engines. Now, even though the spacing of the mains and the main journal sizes, everything is exactly the same, the cranks will not physically fit in there because the counterweights are very large and there just isn't enough room in this small block package. So you have to modify the crank quite a bit to get it to fit in there. But once you remove or once you remove material from the counterweights and once you reduce the diameter of those counterweights, it'll fit right in there like a glove, and also give you some cubic inch. You know, this one here originally was 350 cubic inch, and by putting that big block crank in there, you're always over 400 inch in some way, shape, or form, depending on what stroke you decide to put in there. We're using Cleveite main bearings, and these things here have been 100% reliable for me. I mean, there's other manufacturers out there, other styles, but I've never, not once, had an issue with a Cleveite bearing, so I stick with them. Another thing is throughout the years, guys have modified the oil holes for increased oil flow. Throughout these years, I've backed off on these modifications and never found an issue. My own personal racing engine that makes 1,200 horsepower, take the bearing out of the box, put it in. They're perfect just the way they are. There's no reason to mess with them. Before I drop the crankshaft in, I put a thin layer of engine oil on there. A lot of people put all kinds of different lubrications on there, break-in lubes, thick EP lubricants, Molly. You know, I've seen guys do all sorts of things, but I'm gonna tell you what, oil works. The biggest reason that I have for using the engine oil is when you put the crankshaft in the engine, you want to make sure that this thing spins like it's on roller bearings. And if you have some thick sort of lubricant, you can turn the crank and everything, but you can't feel if there's a bind or any sort of an issue somewhere. Nobody ever plans on having an issue, but you just won't catch it unless you have engine oil. So when I put the crankshaft in, I will set it in there with no rear main seal so that there's no drag anywhere. You torque this crankshaft down, you should be able to just spin this thing as easy as can be. That will tell you that everything's A-OK there. This here is a factory forged steel 425 crankshaft. In order to fit in this small block engine, a couple of things have to occur. This is not just a bolt-in deal. The counterweights have been trimmed on the lathe, usually about 250 to 300 thousandths for it to physically fit inside the block. The second thing that has to be done is the rod journals have to be cut down to a 2200 big block Chevrolet size. They're originally factory 2500, and that allows the use of big block Chevy rods, and again, it allows the OD of that connecting rod to be physically smaller so that it'll all fit inside this block. The third thing, once you start cutting the counterweights, it affects the balance severely. A lot of times, if not all the time on these applications, you'll need quite a bit of Mallory inside the front and rear counterweight. And Mallory is, each one of these slugs is 25 bucks a piece for, you know, my cost to buy. You got 4 slugs plus a little one, plus the time to bore and ream, press in, weld. So whenever you get into a job like this, there's an awful lot of work that goes into this crankshaft to fit inside that block. But instead of having a 350-inch motor, you have a 420-inch motor. So it's the way to do it. The only other thing special about this crankshaft is you have to pay attention to surface finish on the journals. Typically, when it comes off the crank grinder, it doesn't have a very smooth finish. If you look at it with a very high-powered microscope or handheld microscope, boy, I'll tell you what, even though it looks good and ground to the eye, when you look at the journal under this 60 power microscope, boy, it looks like just little claws are just waiting to grab your bearings. So we've done a lot of research as far as getting the surface finish down to an acceptable level where it won't destroy the bearings on startup or under high load. But those are the kind of things that we've done to this crankshaft for this build. These Aarp Studs, these are an excellent thing to use for these applications. One, you'll never tear up a thread by torquing up a bolt in the block, and two, it makes everything more rigid.